The electron configuration for atoms or ions is showing the distribution of the electrons in an atom. We know that the three subatomic particles, the protons, the neutrons, and the electrons, out of the three, the protons and the neutrons are located in the nucleus, and then we have the electrons in different energy levels, and in those energy levels we have what is known as orbitals. So we have different types of orbitals S, P, D, F. Depending on the type of orbital that we have, we're going to have a specific number of each one of them. For example, whenever you have an s orbital, there's just one s orbital available. We have s orbitals in all of the different energy levels, and that's given by the quantum numbers. P orbitals, we start having p orbitals on the second energy level, and then we have 3p orbitals. Wherever you see a p in my list here to write down the electron configuration, you actually have 3 of them. And then for d orbitals, we start having d orbitals in the third energy level, and for those we have 5 of them. We don't have f orbitals listed here, but we do have f orbitals, and we have other types of orbitals after f. Actually, after f we have g orbitals, and it keeps going in alphabetical order after that. We're not writing down electron configurations for anything that requires to use f orbitals. So what I did here in my list, the letters that I wrote, X, Y, and Z, represent the number of electrons that you can have in each type of orbital. There's a rule that is telling you that in every orbital you cannot have more than 2 electrons, and that's because you cannot have the same set of 4 quantum numbers describing 2 different electrons. So out of the quantum numbers that we have 4 of them, and they are actually specific quantum numbers for each electron that you have. So you cannot have more than 2 electrons in the same orbital because you will have to use the same quantum number for the electrons, and that's not possible. So whenever you have the letter X here on my list, your number of electrons can be 1 or 2, or up to 2 electrons. When you have p orbitals, since we have 3 of them, the Y that I am assigning for p orbitals, it can start at 1, but it can go all the way to 6 because you have 3 orbitals and you can have up to 2 electrons in each one. So your number of electrons can go from 1 up to 6. If you have the d orbitals, since d orbitals we have 5 of them, whatever in any energy level in which you have d orbitals, you're going to have 5 d orbitals. In each d orbital you can put up to 2 electrons, so you can have a maximum number of electrons that it goes up to 10. Okay? So the letter X up to 2, the letter Y up to 6, the letter Z for the d orbitals up to 10. Where do you stop adding the electrons is going to depend on the total number of electrons that you need to arrange in those energy levels in those specific orbitals. Now the same thing is going to apply to ions. Okay, your ions they are going to have different number of electrons depending on the charge that you have, right? You know that you can have positive and negative ions. That's going to depend on if the atom is losing or gaining electrons. Anything that is losing electrons is going to give you ions with positive charges because it's losing negative charge because electrons are negative. So when you have your atoms as neutral, you have the same number of protons, which are your positive charges, and the same number of electrons, which are the negative charges. If you have the same number of positive and negative charges, you don't have an overall charge. Now, when something starts losing electrons, you're removing negative charge, which means that now your number of positive charges is going to be greater than the number of negative charges, and you will have an overall charge that is a positive number. For the negative ions, you're going to have an overall charge that is a negative number, and the reason is that negative ions, the atoms are actually gaining electrons. So you start with the same number of positive and negative charges, but as you keep adding more negative charge, now you don't have enough positive to cancel all of the negative charges, and you will end up having an overall charge that is a negative number. We can kind of predict the charge based on the periodic table. So depending on the group number, and remember, I'm using my own numbering for the groups. I have groups 1 through 8 for the main groups only. I'm not using letters A or B. I'm not using Roman numbers. I'm not using the usual numbering from 1 to 18. I'm using 1 to 8 for the main groups on the periodic table. So elements in group 1, they're going to form ions with a charge of +1, and you can see the possible charges for everything, and that's in general. So if you think about the arrangement of the elements on the periodic table, on the left side we have the metals, on the right side we have the non-metals, and then we have the metalloids separating those groups. So if we have the metals on the left side, and as you can see for those groups, I have group number 1, 2, and 3, and I have positive charges assigned for those ions, we can predict that in general for the metals, we're going to have positive charges. So metals, they tend to lose electrons to form ions with positive charges. And then on the right side of the periodic table, groups 5, 6, 7, for those groups, we have negative charges assigned to those groups. So it means that the nonmetals, they tend to gain electrons because the nonmetals are those elements that you have towards the right side of the periodic table. For group 4 and group 8, for group 4, we don't have a specific charge that we can assign using the periodic table. We can kind of predict what charge you're going to have for those elements when they are forming ions based on what you have combined with them, but not using the periodic table. And then for group 8, you have the noble gases or inert gases, so they don't want to lose or gain electrons. There's a reason why, so that's why we're going over. So I'm going to do here one example for the electron configuration for sodium, element number 11. And let's do one with a negative charge. So I have a metal and a non-metal, okay? So electron configuration for sodium, it's 11 electrons in total, and I'm writing down the electron configuration for the neutral element, okay, for both of them, sodium and nitrogen. I have 11 electrons in sodium, so I start in 1s, and that will be 2. So I'm stopping at 3s1 on the electron configuration because I just need 11 electrons, so that's giving me my 11 electrons. 1s2, 2s2 to p6, that's 10, and then I have 3s1, that's 11. If we do the short notation, that is going to look like this, and not Na, but Ne for neon, okay? Neon is giving you the 10 electrons, which is what you have up here. Is the noble gas that you have right before sodium. So we use that one in brackets with the symbol, so you know that that's representing neon, or the electron configuration for neon, which has 10 electrons. And then what comes after, which is the 11th electron for sodium, you can just write that down using the periodic table. Sodium is in period 3, and then it's in group 1, and for group 1 we have S1. So I'm going to do for nitrogen with 7 electrons. Electron configuration 1s2, 2s2, and that's 4, and that will be 3. That's 7 electrons. Okay? If you want to do the short notation for that electron configuration, the noble gas that you have to use is going to be helium, because neon it's after nitrogen, and we always use for the short notation the noble gas with a lower number of electrons. So for nitrogen it will be helium. Helium is just 2 electrons, so you need to complete everything else from the periodic table. It's in period 2. You have to pass from helium towards the left side of the periodic table where you have your 2s2, lithium, beryllium, and then you move towards the right side of the periodic table and you will end up with your 2p3 again. So this is 2 electrons here for helium, and then you have 2 here, that's 4, and then 3 in the p orbitals, that's a total of 7 electrons. That's just writing down the electron configuration for the neutral elements. Now, if you want to write down the electron configuration for the ions, right, the first thing that you have to do is to determine what's the charge of the ion. So for example, if you're writing down the electron configuration for the ion of sodium, sodium is in group 1, and you have right there in my note that any element from group 1 is going to form ions with a charge equal to +1. So the ion of sodium is going to look like this. The positive sign is telling you that that element is losing electrons, and then the magnitude of that charge is telling you how many electrons that atom is losing. So sodium with a charge of +1, or the ion of sodium, is going to have 10 electrons, not 11. 11 is what you have for the neutral element, 11 protons, 11 electrons. So when you have the charge of +1, it's losing 1, and your number of electrons go down from 11 to 10. So if you're writing down the electron configuration for sodium +1, you're not writing down electron configuration for 11 electrons. You're writing down the electron configuration for 10 electrons, which is going to look like this. Now for the second one, electron configuration for nitrogen. First, determine what's the charge of the ion of nitrogen. So we have nitrogen, it's in group 5 of the periodic table. You can check that. So the charge is going to be -3. So if you have nitrogen with a charge of -3, the negative sign is telling you that it's gaining electrons. Okay? So you have in the neutral atom of nitrogen 7 protons, 7 electrons. When you have in nitrogen the ion, you have a charge of -3, which means that the atom of nitrogen is gaining 3 electrons. So you have to write down the electron configuration for nitrogen, but not with 7 electrons, but with 10 electrons, because to your original number 7 you're adding 3 electrons, because the charge is a negative number, which means that that atom is gaining electrons. So for both of them, okay, for those two elements, a metal and a non-metal, we have an electron configuration for the ions, which is giving you 10 electrons, which is the electron configuration of neon.